Hello there, it's Alana Tucky, and I'm going to be lecturing here over section 7.4, which is solving quadratic equations using the completing the square method. Okay, so far we have two methods for solving quadratic equations. We've learned how to factor. That was section 6.6, if you want to know it. I'll write it down. Section 6.6. That works really well if you have it so that it's ax squared plus bx plus c equals 0. If the equation's set equal to 0, and then if that left-hand side factors, then it works. If the left-hand side doesn't factor, you don't know how to do that. All right, then you have the square root method, which we learned in 7.3 part 2. Which says that if you have it so that you have a times x minus h squared plus k equals j, where a, h, k, and j are all numbers, you can basically manipulate it so that you can take the square root of both sides, right? But you have to look kind of for that parentheses squared business to be able to use this method. So that leads us to completing the square. Now, completing the square does not have to be used for solving quadratics. It just is in this example. But you can actually complete the square all over the place. It's a nice, handy little technique to know. So it's going to work for all quadratics, no matter what. It's going to work for everything. It doesn't have to factor. It doesn't have to have that parentheses squared business, at least at the beginning. You're going to manipulate it so that it does have it. That's kind of the point of completing the square. You'll be taking your equation that starts off ax squared plus bx plus c, and you're going to manipulate it so that it turns into like an x minus something squared or an x plus something squared in parentheses. And then you'll be able to use the square root method from there. That's why it's completing the square, because you're wanting to use the square root method, which isn't that hard from the last section. Okay, so this method works by creating a perfect square. You're going to be doing something to make it so that it's perfect parentheses squared that did not originally fit the form of the square root method. So let's back up for a second and think about what a perfect square looks like. If you're going to make things turn into perfect squares, it would help if you knew what they were. So a perfect square, like x plus 6 squared, is x plus 6 times x plus 6. All right, now think about that when you FOIL it out, distribute it out. First would be x squared, outers would be 6x, inners would be 6x, and then last would be 36. Okay, so that would be x squared plus 12x plus 36. Now notice this middle term right here is double this guy, right? So if you take, I'm going to call this, let me type this in, hold on one sec. There we go. Okay, so here's 6. And then when I do outers plus inners, I get 6 plus 6, which makes 12. And 12 is 2 times 6, right? And then for the last, I get 6 times 6, which is 36, which is n squared. See it right there? All right, so that same idea will hold true over here for this one with x minus 3 squared. Let me type that up one sec. There we go. So I have x minus 3 times x minus 3. So n is minus 3, right? It was negative 3. And then what I'm doing is I'm multiplying. So x squared, so x times x, that's x squared, right? And then x times negative 3 is negative 3x. X times negative 3 is negative 3x. So outers and inners are both negative 3x. So when you add them, that makes negative 6x. Right, there's your outers plus inners. And then your last is negative 3 times negative 3, which is 9. And you can see negative 6x is 2 times n, right? 2 times negative 3. And 9 is negative 3 squared, which is n squared. So we've learned a valuable lesson. A perfect square trinomial, if you have x plus or minus n squared, that would be equal to x squared, let's see, plus or minus, it depends. So if you have plus 6, then it's plus 2n x 2n. I can type, there we go. And then plus n squared, right? It's always going to be that, because your middle term is always going to have the x in there, and then it's double what your n value was. So the first one we did, it was 12, because 2 times 6 was 12. The second one we did, it was 6, because 2 times 3 is 6. And the plus sign goes with whatever the sign was. So it was positive in the first one, so it's positive. Negative in the second one, so the middle term's negative. The last term is always positive, because when you square a negative, it turns positive. And when you square a positive, obviously it stays positive. So there we go. So that's what a perfect square trinomial looks like. That's what those are called, a perfect square trinomial. Trinomial because it's got three terms, first, second, third. Perfect square because it's made from squaring this little binomial thing right here. Okay. All right, so now we're going to use that to solve by completing the square. Now this whole method up here, this idea is not used only for solving quadratics, but in intermediate algebra it becomes the big part for our course. And it has a bunch of different steps. So the first step is that we're going to have to make it so that it's of the form ax squared plus bx equals k. Then if a is not 1, we're going to have to divide by a to make it 1. Then we're going to complete the square. That's this technique over here. We're basically going to try to figure out what we can do to make it turn into a parentheses squared. That's our goal, right? And then solve the equation using the square root method that we learned in the last section. Okay, so I typed this up. Let's get this in here. All right, step 1, we need to subtract the 9 so that it's ax squared plus bx, which in our case is 8x, equals negative 9. We're subtracting 9 from both sides. Matter of fact, I'll put it in there. Minus 9, minus 9. Okay, so now step 1 is done. It said to write the equation in the form ax squared plus bx equals k. Done. Step 2, if a is not 1, but our a is 1. That's the number, the leading coefficient, the coefficient for your x squared term. So I can skip step 2. That's done with that. Step 3, complete the square. Now there's the hard stuff. Okay, so we need to complete the square. We need to figure out what we can do, because what our goal is to turn it into x plus something squared equals something, right? That's our goal. We want a perfect square. All right, now let's go back and look just back here a second. We said that the middle term, the one that's multiplied by the x, is equal to 2n. See it right there? So if I could use that idea, I could figure out what my n is, and that'll be what's inside my parentheses. Interesting. Okay, so let's go to our problem and look at the middle term for a second. So actually, I want to cut some steps out here. So hold on one second. Okay, there we go. And then I'm going to say note. Okay, so 8 is equal to 2n, right? Because your middle term is that 2n value, if it's a complete perfect square, right? If it's a perfect square, the middle term is the 2n value. Okay, so let's look it over. If that's the case, then n is 4, right? And then while I'm on the subject, n squared would be 16, right? So I had 8 from the middle term, right? Because of the 8 equals the coefficient of the x, right? So since 8 is the coefficient of x, that's 2n. Then n is 4. You just divide both sides by 2. You'll get n is 4. And then you square it, and you're going to have 16. Okay, so there's a little note to ourselves, a little aside. Okay, so now how does that help us? Well, what we're going to do is we're going to take this value that we had here, and we're going to write it a different way. We're going to say, okay, I want to change this so that it's x plus n squared equals something. Now n, we just figured out, was 4. So n is 4. And negative 9 was what it was equal to, but I'm going to add n squared to that, which is 16. Let me put it to you this way. Here's what we're doing. So it's x squared, oopsie, not there, x squared plus 8x plus something equals negative 9 plus something. You're adding on something to both sides to turn it into that perfect square trinomial that you want. And that something that you're adding in is the n squared. It's 16. So you're making it x squared plus 8x plus 16. And if you add it over onto the left-hand side, you're going to have to add it into the right-hand side. So equals negative 9 plus 16. There we go. So negative 9 plus 16. Then this part over here perfectly factors every time because you set it up this way. By adding n squared here and adding n squared over here, you're making it so that it turns into this perfect square trinomial. Okay, but this perfect square trinomial, if you FOIL it out, you're going to have right up there. So in other words, you're figuring out what number you could add on to both sides to turn it into this parentheses squared business that you want so badly. Now, why do you want it so badly? Well, because from this point on, it's not hard to solve. You get x plus 4 squared equals 7, right? Because negative 9 plus 16 is 7. Then you take the square root of both sides. This is what we learned in the last section, right? Square root over here, plus or minus square root over here, right? Then you'll have x plus 4 equals plus or minus the square root of 7. And that means x equals negative 4 plus or minus square root of 7, because you just subtract 4 from both sides, and you're done. That is solving by completing the square. It's not pretty, but it works. It works every time. It works for all quadratics, no matter whether they were factorable, which this one was not. Basically, what you're doing is you're changing it from the form it came in. It came in this x squared plus 8x plus 9 business, and you fiddled around with it. You added something on so that you could turn it into x minus 4 squared or x plus 4 squared. All right, let's practice another one. So, because this is kind of confusing. So let me type this up. Okay, so I start off with x squared minus 2x plus 13 equals 0. We subtract 13 from both sides. We're trying to get the x squared and the 2x together on their own side. So you get x squared minus 2x equals negative 13. You are done with step 1. Now step 2 is where the hard part is. Actually, let me label these steps for you. Hold on one second. There we go. I highlighted it for you so you could see better. Step 1, we got x squared by itself, or the x squared plus 8x by itself. Step 2, we didn't need to bother with. Step 3, you figure out what your n squared is and your n is and all that stuff. Then you add your n squared to both sides, and that turns it into that perfect square trinomial thing. And then step 4, you just solve that with the square root method. Okay, so let me copy that over here on our side. All right, I copied and pasted it. Let's see here now. For our particular problem, 2n is negative 2, right? Because negative 2 is the coefficient of x. If that's the case, then n is only negative 1, right? Let me double check that. Yeah, negative 2. Our coefficient was negative 2. So that means n is negative 1. Oopsie, not there. Come here. N is negative 1, and n squared is positive 1, because negative 1 times negative 1, here, that's negative 1 squared, which is positive 1. Okay, so we're going to add positive 1 to both sides of our equation. So let's go here. So it's x squared minus 2x plus something equals negative 13 plus something. So that's x squared minus 2x plus, and then we add in that n squared, which is 1, equals negative 13 plus 1. All right, now this over here on the left is automatically x minus n squared, and n was 1. So equals negative 13 or negative 12, right? Because when you take negative 13 and you add 1 to it, you get negative 12. All right, so now, and it just occurred to me that I could have added back here, so I did. Negative 9 plus 16 is 7. All right, so now that I know it's negative 12, I'm going to have to take the square root of both sides. So I get x minus 1 squared equals plus or minus the square root of negative 12. Okay, that's x minus 1, because when you take the square root of both sides, you're going to get x minus 1 equals plus or minus, and now we're going to have to fiddle with this. You got to take an I out, and 12 is 4 times 3, right? Okay, so we're going to have to do another step. X minus 1 equals plus or minus 2i square root 3, because the square root of 4 is 2. And then we just add 1 to both sides. And those are not like terms, so you're just going to be stuck. 1 plus or minus 2i square root 3 is your final result. Like that. Again, it's not pretty, but it will do the trick. Oops, I just made that extra step there disappear. All right, we'll do some more of these in the next video. See you then.